Welcome to another session of Grade 9 Mathematics, Chapter 7 Triangles. Dear students, in this fourth part of the chapter, we'll be discussing in detail the solutions for NCERT exercise 7.3. Let us quickly get to the first question of exercise 7.3. The first question says, that triangle ABC and triangle DBC are two isosceles triangles on the same base BC, and vertices A and D are on the same side of BC. See figure. Now, if we could see figure, where is triangle ABC? Yeah, so triangle ABC is the bigger one and triangle DBC is a smaller triangle which has got two isosceles and on the same base BC. So they are on the same base BC. Yes. And vertices A and D are on the same side of BC. So I've got a same base BC. And if we could read the question, it says, if AD is extended to intersect BC at P, we have been asked to prove that triangle ABD is congruent to triangle ACD. Triangle ABP is congruent to triangle ACP. The third part is AP bisects angle A as well as angle D. And the fourth part is AP is the perpendicular bisector of BC. Let's quickly get to the solution. Dear students, as you can see in the figure and what we have been asked to prove, let's first consider triangle ABD and triangle ACD. Now, when you consider triangle ABD and triangle ACD, you will find that there are a few given facts. One is that AB is equal to AC. Fine. They are isosceles triangles, so AB is equal to AC is the given fact. Similarly, BD is equal to CD because triangle BDC is also an isosceles triangle. So that is also a given fact. What is common to both the triangles? Yes, the side AD. So it has been given that AB is equal to AC, BD is equal to CD, and AD is equal to AD. So we can say that triangle ABD is congruent to triangle ACD. Which congruency rule? Yes, SSS, that is side, side, side congruency rule. Now, which helps us to prove the first part. What is the second part that we're supposed to prove? The triangle ABP is congruent to triangle ACP. Let's do that. Let's consider triangle ABP and triangle ACP. Now, again, what is given is AB of triangle ABP is equal to AC of triangle ACP. And I can also say that angle BAP is equal to angle CAP. Why? Because I've already proved in the first part of the solution that triangle ABD and triangle ACD are congruent. If that's the case, then the corresponding part, that is angle BAD, will be equal to angle CAD. If BAD is equal to CAD, and if I extend AD further, I can write BAP is equal to CAP. I hope that's clear. Yes. So then, what is the common part for both the triangles? Yes, the side AP. So what have I proved as of now? That AB is equal to AC, angle BAP is equal to angle CAP, AP is equal to AP for both the triangles, which helps me to conclude that triangle ABP is congruent to triangle ACP by SAS congruency rule, that is side angle side congruency rule. Now let us get to the third part of the solution. Now, what are we supposed to prove? that AP bisects the angle A as well as angle D. Now, to prove that, let us try to understand what we have got from the first part. Can I say that ABD is congruent to ACD? Yes. If that's the case, then angle ADB is equal to angle ADC? Yes, by CPCT. What I'm going to do is, I'm going to subtract these angles from 180 degree. So 180 minus angle ADB is equal to 180 minus angle ADC. Also from part 2, we can see that angle BAP can be written be equal to angle CAP. Again, CPCT. Now, with this, I can conclude that AP bisects angle A as well as angle D. Now, let us get to the fourth part of the solution. Here in the fourth part, we have been asked to prove that BP is equal to CP. Now, how shall we prove that? If BP is equal to CP, we can actually prove that AP is perpendicular bisector of BC, which is the actual thing that has been asked, right? So, now BP is equal to CP is a given fact because I've already proved that the triangles are congruent. Yes. And angle BPA is equal to angle CPA. That can also be stated by CPCT. Now, at the same time, if I add angle BPA and angle CPA, the answer should be 180 degree. That is, angle BPA plus angle CPA should be equal to 180 degree. Why? Because they form linear pair of angles. But then at the same time, they are equal. So what can I do now is, instead of writing angle BPA plus angle CPA, we can directly write 2 angle BPA is equal to 180 degree. So the 2 goes to the other side, becomes 180 divided by 2. Hence, angle BPA is equal to 90 degree. So I have proved that angle BPA, that is angle P is 90 degree, as well as BP is equal to CP. So what does that mean? That AP is the perpendicular bisector of BC. I hope you all are clear with the solution to this question number 1 of this particular exercise. Now let us get into question number 2 of exercise 7.3. Question number 2 says that AD is an altitude of an isosceles triangle ABC in which AB is equal to AC. So here there is no figure given, but it has been mentioned in the question that AD is an altitude of an isosceles triangle ABC. How is it isosceles? Wherein AB is equal to AC. We have been asked to prove that first AD bisects BC and AD bisects angle A. Let us get to the solution. Now this is how the figure may look like. Triangle ABC, wherein AB is equal to AC is a given fact. Okay. Now let us consider triangle ABD and triangle ACD from the figure. Look at the figure and say, where is ABD? Yes, here it is, triangle ABD and triangle ACD. Now, when you compare these two triangles, you can easily say that angle D is 90 degree for both of them. Yes. So, angle ADB is equal to angle ADC because both of them are 90 degree each. Also, it is given in the question that AB is equal to AC. AB of triangle ABD is equal to AC of triangle ACD. And at the same time, what is common to both? The side AD. Now, which rule does it apply over here? Hello, my dear students, we have got a 90 degree as one of the angle. So let us check whether RHS does apply over here. So RHS, right angle. Do we have a right angle? Yes, we have a right angle. H stands for hypotenuse. Are the hypotenuse equal for both the triangles? Yes. AB is equal to AC. AB of triangle ABD, which is a hypotenuse, is equal to AC hypotenuse of triangle ACD. So even the hypotenuse is equal. And one of the sides, that is AD of triangle ABD, is equal to AD of triangle ABC. Hence, I can say that triangle ABD is congruent to triangle ACD by RHS congruency rule. Now, if they are congruent, in the next line I can easily write that BD is equal to DC. Why? CPCT, corresponding part of congruent triangle. Now, if BD is equal to DC, it easily concludes that AD has bisected DC. I hope the first part of this solution is clear to you all. Now, my dear, if ABD is congruent to ACD as I proved in the first part, I can easily state that angle BAD is equal to angle CAD from that proved part. Why? CPCT, corresponding part of congruent triangle, are equal. Now, if these angles, that is angle BAD and angle CAD, are equal to one another, what does that mean? That angle A is divided into two equal parts. And if you could see in the figure, who is going to divide angle A into equal parts? AD. So I can conclude that AD bisects angle A. This was solution to question number 2. Now let's get to exercise 7.3, question number 3, which says two sides AB and BC and median AM of one triangle ABC are respectively equal to the sides PQ and QR and median PN of triangle PQR. See the figure. Now, if you have realized what is been given is AB of triangle ABC is equal to PQ of triangle PQR. BM of triangle ABC is equal to QN of triangle PQR. AM in the figure triangle ABC is equal to PN in the figure triangle PQR, which is a median also. Here we have been asked to prove that triangle ABM is congruent to triangle PQN, as well as triangle ABC is congruent to triangle PQR. Let us use this figure and get to the solution of this question number 3. Now, given that BC is equal to QR, now if BC is equal to QR, the half should also be equal. That is, half of BC should also be equal to half of QR. Who said that? Yes, Euclid's axiom. Now, what is half of BC? Half of BC is BM. And what is half of QR? It is QN. So instead of writing half of BC is equal to half of QR, I shall write BM is equal to QN. Why they were half? Because it is clearly mentioned in the question that AM and PN are medians. Now let me get to the question. What I'm supposed to prove? That ABM is congruent to triangle PQN. So let me consider that triangle ABM and triangle PQN. So if you could see, it's very clearly given in the question that AB is equal to PQ. It is also given that AM is equal to PL. And we just proved that BM is equal to QN. So with these three in picture, that is AB is equal to PQ, AM is equal to PN, and BM is equal to QN, I can easily state that triangle ABM is congruent to triangle PQN by SSS congruency rule. Let's quickly get to question number, second part of the question number 3. Now, here we have been asked to prove that triangle ABC is congruent to triangle PQR. Let me begin with what I've got as of now. I've got that ABM, triangle ABM is congruent to triangle PQN. If that's the case, then angle B is equal to angle Q. That is angle ABM is equal to angle PQN by CPCT. Now if you consider triangle ABC and triangle PQR, AB is equal to PQ is a given fact. Angle B is equal to angle Q. We have just proved that. And it is also given that BC is equal to QR. Considering these three given data, that is AB is equal to PQ, angle B is equal to angle Q, and BC is equal to QR, I can easily conclude that triangle ABC is congruent to triangle PQR. Which rule does it satisfy? Yes, it gets satisfied by the SAS congruency rule. Side included angle and side. So SAS congruency rule. I hope you have understood the solution to this particular question. Now quickly, let's get to the next question. Question number 4. Here, question number 4 says that BE and CF are two equal altitudes of a triangle ABC. What are BE and CF? They are two equal altitudes of triangle ABC. Using RHS congruency rule, prove that the triangle ABC is isosceles. Here we have been asked to use RHS congruency rule and prove that the triangle ABC is isosceles. Let's do that into the part of the solution. Now, in triangle FBC and triangle ECB, I say it again, triangle FBC and triangle ECB, angle BFC is equal to angle CEB because both of them are equal to 90 degree. At the same time, BC is equal to BC. That is their common side. And also it is given that FC is equal to B. That is the altitudes are equal to one another. Using these three facts, I can conclude that triangle FBC is congruent to triangle ECB. Which rule? RHS congruency rule, because one of them is a right angle, the other one happens to be a hypotenuse, and the third fact happens to be one of the sides, corresponding sides. So by RHS congruency rule, I can conclude that triangle FBC is congruent to triangle ECB. If that's the case, then angle FBC should also be equal to angle ECB. Yes, by CPCT, corresponding part of congruent triangle. Now, if two angles are equal, their opposite sides will also be equal. Hence, AC will be equal to AB. Now, once AC is equal to AB, I can easily say that triangle ABC is an isosceles triangle. So, using the RHS congruency rule, we have proved that, in fact, the triangle ABC is an isosceles triangle. I hope you were clear with the solution to this particular question. Now let us get into the last question of this exercise. Question number 5. Here it has been given that ABC is an isosceles triangle with AB is equal to AC. So ABC is an isosceles triangle wherein side AB is equal to AC. Also, we have been asked to draw AP perpendicular to BC to show that angle B is equal to angle C. So what is the other given fact? That AP is perpendicular to BC, and we have been asked to prove that angle B is equal to angle C. Now, a figure with the given data has been drawn. From that, you can see there are two triangles, triangle ABP and triangle ACP. Now, if I look into the figure, there are few given facts. One of them is AP is perpendicular to BC. That means angle APB is equal to angle APC because both of them are equal to 90 degrees. Also, AB is equal to AC because that's a given fact. AB is equal to AC because ABC is isosceles. It's given in the question. Also, AP, the side, is common to both the triangles. So AP is equal to AP. So with this, it clearly states that by RHS congruency rule, the triangle ABP is congruent to triangle ACP. I repeat, triangle ABP is congruent to triangle ACP. If they are congruent to each other, I can easily say that the corresponding parts are equal, such that angle B is equal to angle C. What is the reason? CPCT. What does CPCT stand for? Corresponding part of congruent triangle. So I hope you've understood the solution to this particular question. With this, we come to the last question or the solution of this particular exercise. Exercise 7.3 is over here. Please practice well so that you can do other sums given in the examination in the correct manner. This is all for now. Take care of yourself until we meet next time with another session. Thank you.